To truly grasp the universe, we must first confront its staggering, almost unimaginable scale. The cosmos stretches far beyond what our senses can perceive, a vastness that humbles even the most curious minds. When you look up at the night sky, remember, each star you see is a sun, many with their own families of planets, swirling in orbits just as our Earth does. All of these stars are gathered together in our Milky Way, a sprawling city of light, which itself is just one among billions of galaxies scattered across the universe. The distances between these stars and galaxies are so immense, measured in light years, the distance light travels in a year, that they defy our everyday experience. Even the nearest star is over 4 light years away, a journey that would take tens of thousands of years with current technology. Yet, this immensity is not a cause for despair, but for wonder. It invites us to dream bigger, to imagine what might lie beyond the limits of our sight and knowledge. Our ancestors once navigated by the stars, using them as guides across unknown seas. They told stories about the constellations, weaving myths and legends to explain their place in the cosmos, and sought to understand the patterns above. That same curiosity now drives us to send robotic explorers and probes into the void, reaching farther than ever before, searching for answers to questions that have echoed through generations. We listen for signals from distant worlds, hoping to catch a whisper from another civilization, and scan the skies for planets that might harbor life. The universe is a place of extremes, of unimaginable violence and breathtaking beauty. Within its darkness, order and structure emerge, nebulae where stars are born, clusters where they gather, and the glowing remnants of supernovae marking the end of stellar lives. Every new discovery, from distant exoplanets to the faintest galaxies, adds another piece to the cosmic puzzle. Each answer sparks new questions, fueling our relentless desire to know. Are we alone? What else is out there, waiting to be found? The exploration of space is a deeply human quest, an expression of hope, ingenuity, and the belief that the next great discovery awaits us in the endless ocean of night. As we gaze upward, we are reminded that our journey has only just begun. In 1977, humanity launched Voyager 1 and 2, our eyes and ears to the outer solar system. Using a rare planetary alignment, they slingshotted from Jupiter to Saturn, and Voyager 2 continued to Uranus and Neptune, revealing worlds we'd only glimpsed as distant points of light. They sent back breathtaking images: Jupiter's storms, Saturn's rings, volcanic moons, and hints of oceans beneath icy crusts. These discoveries transformed our understanding of the solar system, turning distant planets into real, dynamic places. The Voyager's success inspired generations and provided decades of scientific data. But their mission didn't end there. With their primary objectives complete, the probes were aimed at interstellar space, becoming humanity's first emissaries to the stars. Their journey evolved from planetary science to interstellar exploration, pushing the limits of what machines, and we, could achieve. The story of Voyager is one of audacity, curiosity, and the enduring reach of human ingenuity. After their grand planetary tour, the Voyagers pressed onward, venturing into the uncharted outer reaches of the heliosphere, the vast invisible bubble created by the sun's solar wind. Here, the familiar warmth of our star faded, and the spacecraft entered a realm where the sun's influence began to wane, and the true darkness of interstellar space beckoned. Back on Earth, teams of scientists and engineers watched anxiously, waiting for the historic moment when the probes would finally cross into true interstellar space, a region never before touched by human technology, where the environment is shaped not by our sun, but by the collective forces of the galaxy. In 2012, Voyager 1 made history by crossing the heliopause, the boundary where the solar wind yields to the interstellar medium. This milestone was confirmed by a sudden drop in solar particles and a dramatic spike in cosmic rays from distant stars. Voyager 2 followed in 2018, providing a second, invaluable set of measurements. Humanity had finally left the solar nest. Our robotic explorers now drift in the interstellar medium, a mysterious expanse shaped by ancient supernovae, magnetic fields, and the faint glow of distant galaxies. Here, the Voyagers travel through a realm that has existed for billions of years, largely unchanged and unexplored. Their aging instruments, though battered by time and cosmic radiation, still send precious data home. Each faint transmission is like a postcard from the edge of the known, carrying secrets about the space between the stars and the forces that shape our galaxy. These silent sentinels endure, operating decades beyond their original design, charting a course through the unknown. Their resilience is a testament to human ingenuity and the spirit of exploration. Every day they function is a bonus, extending our senses further into the galaxy. With each passing year they journey deeper, sending back data that helps us understand our place in the cosmos. They are our only direct link to the mysteries between the stars, venturing where no spacecraft has gone before, and offering a glimpse into the vastness that lies beyond our solar system. The Voyagers continue their journey, forever moving away from the pale blue dot they once called home, carrying with them the hopes, dreams, and curiosity of all humanity as they drift into the endless night. For decades, Voyager 1's data stream was faint but steady, an almost imperceptible whisper from the edge of our solar system, faithfully relayed back to Earth by the Deep Space Network. But everything changed on July 3, 2025. On that day, the Deep Space Network detected a signal unlike any before, clear, structured, and utterly baffling, as if the cosmos itself had decided to speak in a new language. The plasma wave system aboard Voyager 1 recorded a sudden intense burst, an energy spike that stood out sharply against the usual cosmic background noise. What made it extraordinary was a repeating sequence of frequencies far more complex than any known natural phenomenon, almost as if it were composed with intent. It was as if Voyager 1 had stumbled upon a cosmic chord, perfectly placed in the vastness to hear it, an arrangement that seemed too deliberate to be random. Scientists worldwide scrambled to analyze the anomaly. Though the event lasted only minutes, it was packed with information, sparking a frenzy of speculation and excitement in the scientific community. The signal's intricate structure suggested it was modulated, as if carrying a message or data, something more than just a random burst of energy. Every diagnostic test confirmed Voyager 1 was healthy. The event was external, not a malfunction or artifact of the spacecraft's aging systems. The signal hasn't repeated, leaving only a single, tantalizing snapshot, an enigma that deepens with every attempt to decode it. Now the world holds its breath as experts scrutinize the data, searching for patterns, meaning, or perhaps even a message from the unknown. Voyager 1, our silent explorer, has uncovered a new cosmic mystery, one that challenges our understanding of the universe and our place within it. Perhaps this is its most significant discovery yet, a clue to something greater waiting in the darkness. What did Voyager 1 hear in the vast emptiness between the stars? And will we ever truly understand its message? Scientists' first task is to exhaust every possible natural explanation for the Voyager 1 anomaly, leaving no stone unturned in their search. Perhaps it was a rare plasma structure, drifting through the vastness of interstellar space, a shockwave from a distant cosmic event, rippling across the interstellar medium, or an interaction with a magnetar's powerful magnetic field, distorting the signal in unexpected ways. Maybe a solar flare, traveling far beyond the heliopause, triggered the mysterious signal detected by Voyager 1, yet none of these fit the data perfectly. The signal's complexity and unusual modulation defy all known astrophysical processes. This leads to a more unsettling possibility. Could the signal actually be artificial in origin? Until a natural cause is found, the idea, however remote, remains on the table, fueling both scientific caution and a sense of wonder. As we ponder the signal's origin, we remember Voyager 1's own message to the cosmos, the Golden Record. This gold-plated disc, conceived by Carl Sagan's team, is a time capsule, a greeting card from Earth to any who might find it. It holds images of our world, diagrams of our science, and sounds from nature to laughter, music from Bach to Chuck Berry, folk songs from around the globe, and greetings in 55 languages. All are etched into its grooves. The Golden Record is a symbol of hope and curiosity, a testament to our desire to connect. The odds of it being found are minuscule, but the act of creating it unified us and made us reflect on what it means to be human. It's a message that says, we were here, this is our world. Even in the vastness we reach out, hoping someone someday will listen. The Voyager anomaly reminds us why we explore, to push boundaries, ask questions, and seek meaning in the unknown. Space exploration unites us, transcending borders and beliefs. We all share the same sky. The mystery of the Voyager signal is a human mystery, sparking imagination and a sense of global community. The Voyager's legacy will endure, inspiring future generations to dream and discover. They are pioneers, charting a path for those who will follow. As we wait and listen for the next clue, we're reminded that the universe owes us no answers, but will never stop searching. The story of Voyager is our story, curiosity, courage, and hope, daring to ask, What's out there? The voyage continues,